In this video, we will look at how to plot a set of experimental data using Microsoft Excel. The experiment we will be looking at is a biological experiment between the enzyme amylase and starch. We will be looking at the effect of pH on enzyme activity. The experimental data is shown here. We start by opening Microsoft Excel. This part of the window with all of the boxes is called a spreadsheet. Each box has a special name. It's called a cell. Each cell has a unique set of coordinates. So for example, this cell that I've highlighted is A1, and you can see that A1 is in the top left-hand corner of the screen. If I highlight a different cell, in this case, you can see D6. And again, it's been shown in the corner of the screen. So we start by entering the information that we have. So I've just typed pH into that first cell. Notice that pH has a lowercase p and an uppercase h, so it's quite counterintuitive. Once you've finished typing that in, you press the return key on your keyboard. And then you can just go ahead and type in the next piece of data. So in this case, it's a 4. Again, press the return key, and so on. To do the next title, we just click the appropriate cell, and once again, we type in the title that we need. Okay, so you can see that that title is actually too wide for the cell. So we're going to fix that by taking the cursor up to the boundary between columns B and C, and I'm just going to double click the left-hand mouse button. And you can see that the spreadsheet has automatically made that column the correct width. Notice also that for this unit, although the original table had a slash and then seconds, I've put the units in brackets. And that's just because Excel can sometimes get confused when you use the slash symbol, because in Excel that means divide. Okay, so that's just a good tip to remember. So once again, once I've finished that cell, you just click return. It takes you to the next cell. And again, you enter in the data as we did before. Once again, this title reaction rate is a little bit too wide for the column, so I'm just going to double click, and you can see that automatically the column has become the correct width. Now, the units of reaction rate are a little bit complicated, so they're pronounced seconds to the -1, and I don't need you to worry too much about that just now. We just need to be able to typeset it correctly on the spreadsheet. So in order to do that, what you do is you highlight the -1, as I've done there, and then you right click your mouse key. You go down to where it says Format Cells, and then select Superscript, and then click OK. And you can see that the -1 symbol has become a superscript, just as we wanted. Okay, so you can see that these numbers here are all what we call right justified, and that looks a little bit untidy. What I'd like them is to be in the center of each cell. So all I'm going to do is I'm going to highlight the 3 columns, and I'm going to click this center button here. And you can see that has centered everything in the table, so it looks nice and neat. So I want these titles at the top to clearly be titles, so I'm going to make them bold. So what I'm going to do is I'm just going to highlight those 3 cells, and I'm going to go up to the B for bold button, and I'm going to click it. And you can see that they now have a nice bold font, so those are clearly titles. If you want to be a little bit more advanced, you can put a background. So if you highlight them again, and you go to this paint bucket here, and you find a little arrow next to it, click it, and just scroll down, and we want a nice pale background, like that. So we have completed the experimental results table. So we have the titles, we've got the units, and we've got the numbers that we've been given. The next thing we need to do is to work out the reaction rate for each of the 4 experiments. So if you look back to the original question, we do that by taking 1 and dividing by the time taken. Okay, and that will give us a number that we can consider to be the rate of the enzyme reaction. So obviously, an enzyme reaction that takes a very long time would have a very slow reaction rate. Okay, so the way we're going to do that is I'm going to highlight the cell, and I'm going to go up to this little bar at the top, which is called the formula bar. I'm going to click it. We're going to get Excel to work out something for us. So whenever we need to do that, we start by pressing the equals sign. And then we type what we want Excel to do. So in that cell, which is called C2, we want it to take the number 1, and then we want it to divide that by what is in B2. So notice that that forward slash, as I mentioned previously in the video, means divide. Okay, so what I have here is 1 divided by, and we want this number here. So I'm just going to click cell B2, and you can see that B2 has appeared in the formula bar. And now if you press return, Microsoft Excel will automatically calculate that number for you. Now, we could do exactly the same with the 3 other cells, but there's actually a much faster way of doing it. So Excel knows that this is an experimental results table, and it knows that if we want to carry out a calculation on that cell, chances are we want to do the same with the other 3. So we actually don't need to keep typing out the formula. What we can do is we can highlight the first one, go to this little square in the bottom right, and drag down to the bottom of the table. And if you do that, Excel will automatically work out each of those reaction rates for you. It will use the formula from the first result and then automatically calculate the others. Okay, so the next thing that I want to do is I want to sort out the number of decimal places that we've got here. So we want it to be nice and neat, we want it to be nice and consistent, and at the moment it is neither neat nor consistent. So what I'm going to do is I'm going to highlight these numbers, and I'm going to go to where it says number, okay, just at the top here, and I'm just going to click this little symbol in the corner. And I'm just going to scroll down to where it says number. And you can see here that I can choose the number of decimal places that we can use. So we're not going to worry too much about the number that I'm going to choose here, okay, because our main aim is to be able to draw the graph. But given that these last 2 are to 2 decimal places, I think it makes sense if we give all of our numbers to 2 decimal places. But having done that, I can see that it's made cells C2 and C5 the same, which I'm actually not very happy with. So I'm going to change it to 3 decimal places, just so that I've got a little bit of difference there. Okay, very good. So I've finished doing the results table, and I've got Excel to do the calculation for that final column. Now we're going to get Excel to plot a graph for us, and we want the graph to be pH, which is going to be on the x-axis because that is what we have control over. That's called the independent variable. And we want the reaction rate to be on the y-axis, on the vertical axis, because that is the dependent variable, what we're effectively measuring. So to do that, what I'm going to do is I'm just going to click this box at the top that says A. And when you do that, it highlights the whole of column A. I'm then going to hold down the control key, which is on the bottom left of my keyboard, and I'm going to click column C. And again, when I do that, it highlights the whole of column C. Now, again, Excel's really clever. When you have a results table like this, it knows that the column on the left-hand side is the independent variable, and it knows that the column on the right-hand side is the dependent variable. So when I go to Insert at the top of the page, and I go to this section here which says Charts, I'm just going to click this symbol here. Okay, so I've got 2 sets of numbers. So normally that would be some sort of line graph. So in Excel, the way you'd start that is by clicking XY scatter. So I'm going to click that, and I'd like a set of points, and I'd like them to be joined by a smooth curve. Now again, Excel is really useful here because if you hover over each of these options, you can actually see what the graph's going to look like. Now, you've obviously looked at textbooks and we've looked at various graphs in class, and this sort of experiment, okay, tends to be points linked by a smooth curve. So I'm just going to click that there, and you can see it's inserted the graph into our spreadsheet. Okay, there's still a little bit of work to do. Okay, so I'm not very happy with that title. Okay, it looks a bit messy, the units don't quite work. There should also be titles on the 2 axes. Okay, so I'm just going to click that graph, and if you go up to where it says Quick Layout and click it, you can see that I've been presented with 11 options. And again, Excel's really useful because you can just hover your mouse over each option and choose the one that is most suitable for what you want to do. So I really like this one here on the bottom left, which is called Layout 10, and I'm just going to click that. So you can see it's given me quite a nice graph. I really like those grid lines, and it's given me space to put the 2 axes titles. Okay, so we don't really need this data label because we've just got one data set, so I'm just going to click it and then press delete on my keyboard. Right, so the horizontal axis, the independent variable in this case is pH, so that's what we've got control over. Remember, pH doesn't have any units, it's a little p and an uppercase H. Okay, the vertical axis, okay, so it's a bit weird, but same idea. You highlight it, and then you can actually type what you need. So in this case, reaction rate. And again, I'm just going to put the units in brackets, and then if you click one of the cells, we have that there. So that's all done. The only thing I need to change now is this unit. So again, if you highlight that unit, right click, go down to where it says font, and click superscript. It will automatically make that -1 a superscript as it should be. So the graph is now complete. There are just two things that I want to do to finish it off. The first thing is to change the colour of the line. So it's currently a blue line. I'd like that to be a red line. So what I'm going to do is I'm going to click on the graph and I'm going to go up to where it says change colours, and I'm going to choose a nice orangey red line like that. The next thing I'm going to do is I'm going to change the pH axes. So this graph doesn't fill a very big proportion of the graph paper. Okay, so we don't actually have any data for these low pH values. So I'd quite like the axes to start at pH 3. So the way I'm going to do that is by clicking on that axis and right clicking and then going down to format axes. And if you do that, you can actually choose where the minimum is. So I would like the minimum to be 3.0. And then if you just click the X in the top right, the graph will automatically change. And you can see now we have a nice graph. It fills all of the graph paper. We've got a nice orangey red line, and we've got the correct axes titles. The last thing I'm going to do is I'm going to move this graph into its own sheet so that we can easily print it if we wanted to. So the way you do that is by clicking it, right-clicking your mouse, and moving down to where it says Move Chart. And if you click that, at the moment, this chart is what we call an object in Sheet 1. Okay, so this tab that I'm in just now is called Spreadsheet 1, or Sheet 1 for short. And I'm just going to move it to its own chart. Okay, click OK. And you can see that it's now moved the graph to its very own chart. And this is really useful if you want to print it.